Hi, in this video, we're going to discuss how to use embedding layers in NLP models. As you saw earlier in the lesson, a natural language processing model is a model designed to understand and process human language. These models can be used to do things such as analyzing what was said, or even used to generate new conversations. AIs such as ChatGPT are using a form of natural language processing. Like other models, the text input needs to be numeric. So the first part of the process is converting and normalizing the text. This process was covered in more detail earlier in the lesson, but recall that it was a three-step process including converting words to numeric values, creating numerical sequences, and adjusting these sequences to be the same length. NLP models are used for several different situations. A common one that you will be implementing in this lesson is a sentiment analysis, where you look at something like a store review and determine if the review is positive or negative. This type of model is known as a supervised model. In a supervised model, labels are used with training data to establish the relationship between the input and output. For example, the training data may look something like this. Each review text is labeled as either positive or negative so that the model can determine what language is used in a positive review versus a negative review. In a later lesson, you will take a closer look at unsupervised models. At a high level, the data that comes into an NLP model can be represented as a point in a graph. Each word is represented as a unique data point. In this view, the data is said to be low frequency and high dimension. In other words, there are not a lot of common words and there is little organization to the words. An NLP supervised model uses an embedding layer to group similar words together and form clusters of words. These help the model to have fewer dimensions and higher frequency in each dimension. In other words, the embedding layer takes individual words that are scattered all over the place and groups them into a few clusters made up of many words. For example, a cluster of good words can form on one side of the model, and negative words such as bad are on the other side. The gray dots you see in the middle represent ambiguous words. For example, the word spaghetti is neither positive or negative, so it would be someplace towards the middle. Using this mapping, the model will take a review and predict the sentiment to be either positive or negative based on the mapping of the words. Let's take a look at an NLP model. You should notice many similarities to the previous models you've seen. For example, it ends with a flattening layer and two dense layers. Before that, you'll see the embedding layer. This is the layer that looks for the similarities in the words. Notice that it takes several parameters, two of which you've seen before. The embedding dimension is an integer that determines how many different dimensions are needed to create the model. Think of the embedding dimension similar to nodes in the other models. The more dimensions you have, the more complexity the model can handle. The final layer is a dense layer with one node. The final output is a decimal number between 0 and 1, representing how likely the review is to be positive or negative. When looking at the model fit command, you again see many similarities. The first two parameters are the input data represented by a list of padded reviews and the sentiment value for each of these reviews. After specifying the number of epochs, you pass the validation data. Again, this is done with two lists. A list for the review text and a list for the review labels. Once the model is completed, you can then use the model to predict a value. Notice that the review that you want to predict still needs to go through the tokenizer and pad sequence. Then using the model predict command, you can pass the review to be scored by the model. The final output will be a value between 0 and 1. Since our output uses 1 for positive and 0 for negative, the higher the value, the more likely the review is to be positive. In this case, the value indicates that the model predicts the review to be likely positive. Now it's your turn to create a sentiment model.